Okay, the second topic you want to learn in algebra is after we've done adding, when we're doing adding or plussing algebra terms, we want to learn the indice rules. Indices are all to do with, they're called powers, indices, or exponents. So they've got different names. So they are, if I've got a letter, say I've got a letter X, and indices are the the numbers that are at the top. So if it's x squared like that, that is exactly the same as writing x times x. It's just a simplified way of writing x times x. Um, when I times them together, it's x to the power of 2. Okay, so indices are the little numbers there. They're also called exponents or powers. Okay, so there are rules in when you're doing algebra when they've got powers like that, and you're doing different types of things apart from adding or subtracting. So we already learned the adding and subtracting rules. Now we want to learn the what happens when you've got letters. You've got letters and you are multiplying, not adding or subtracting. You're multiplying, dividing, or raising to a power. Now, you want to learn all these rules differently. When it's plussing and minusing, we already learned that rule that you can only add or subtract like terms. But when you're multiplying, the rule is you can add indices. You add indices. So I've got an A. There's one term, an A, and there's another term, another A, and my operator's A minus. So I'm going to look at the rule for indices when I'm multiplying, and that means I have to add. So let's have a look at what is the actual indice of this A. That is to the power of 1. We don't write the 1, it's just the letter by itself. Then I'm minusing, multiplying, and I've got another A, and it doesn't have a power, so that means it's a 1. So what is the rule? You add the indices. So I add the 1 plus the 1, and that means I end up with an A with two of them. So there's the rule when multiplying. So here's my multiplying. Two letters and numbers and stuff, I add the indice. Great. Okay, so let's try it with this one here where they've got different indices. So I've got an A squared and a squared. So what's the rule? Add the indices. That means I basically apply the rule, and it means it's A 2 plus 2. Adding the indices, that means I'm going to end up with A 4. Okay. Add the indices. Now, remember this A times A is just this. It's just A times A. And that A times A, that A squared is the same. It's just A times A as well. So let's put the A times A, and then A again times A. So when I add up all the indices, I've got 1, 2, 3, 4. You get the same answer, A to the power of 4. So this rule here, it works really easily. Just add the indices. Now, can I? What happens if I've got an A squared times B squared? Do I add the indices? No. No, you can't add the indices if the base is different. Now the base is the letter to the power. So the base here is A, and the base here is B. So if the bases are different, you don't add the indices. So it'll end up as an answer, if I was simplifying this, it'll end up as a squared and just b squared. If there's no gaps in between the letters, it's the same as writing times, okay? So you don't add them up if the base is different. So here's an example here. So I've got c to the power of 3, and I've got d to the power of 2. The base is d and the base is c, so I don't add the powers. Okay, but if I have 3c to the power of 3, and and it's times, and I've got 2c to the power of 2. The base is the same, so we add the indices. So what is this? It's C3 and C2. That means we add the indices. That means it's C5. C5. Yep. So I've added them together. Yeah, great. Got C5. The rule, remember, add indices. And I've got 3 times 2, which means it's a 6. I just do the numbers. So basically I'm dealing with the numbers separately, called the coefficient. I'm dealing with them separately, just as normal times, 3 times 2. And I'm dealing with the C's, the letters with the powers, separately by adding them. Okay, so that is adding and subtracting like terms. Remember if I put a number on the front of this, and I say let's times these two, I deal with the 3 and the 4 first. So I go 3 times 4, and that'll say that's 12. Okay, so I deal with the numbers in the front when I'm multiplying, okay? I just deal with them separately. So that's 12. Then I can go, yep, done that. Got rid of I've done the 3 and the 4. Now I'm going to apply the rules of the C and the D. Can I add them together? No, because the bases are different. So this just ends up being C3 and D2. Sort of see how that works? The numbers in the front, you just multiply together. But if the base is different, they stay the same. But if the base is the same in this case, they're both C's, then that means we can just add them together. Okay. So do the numbers first, multiply the numbers first, and then if the base is the same, add them. Okay. Right, that is the first rule. Hopefully that wasn't too confusing. Because it does get a little bit confusing sometimes, but it's not that hard as long as you remember, you just add, if the base is the same, you just add them together, okay? Right, and just rub out some of these, and we'll go to the next one. Oh, should have made my razor a bit bigger. I want to do one more for multiplying, just to make sure before I move on to dividing that it really makes sense. Okay, so say I've got a 6 b to the power of 3, and I'm multiplying it by a 2b to the power of 4. Okay, now I must simplify this expression. So we notice, first thing we've got to do is we've got 3 rules: multiplying, dividing, or raising to a power. This here operator is multiplying. That means I have to add the indices. So I apply the first rule, add the indices. Okay, so when I'm solving this, I'm going to separate the coefficient, the number in front, and I'm going to do those separately, and I'm going to do them first. So I'm going to go 6 times 2 is 12. All right, that means I've dealt with the letters in the front. Because of my rule, multiplication, I just do those separately, the numbers separately. Now I apply the second rule, and that is if the bases are the same, b's, they're both b's, if the base is the same, I add the indices. So b to the power of 3 and b to the power of 4 is going to be b 3 plus 4, which means there's 7 of them. So 4 plus the 3 means there's 7 of them. So I've added the indices because they're both b's, and I can use the first rule. Okay, hopefully that you've mastered the first rule when you're multiplying terms that have letters in them like that. If they didn't have letters in them and they were just 2 and 6, you would know the answer is 12. But because there's a B involved, a letter with a power there, you have to apply the first rule, add the indices if the base is the same. Okay, right, we've got our first one out of the way. I think we've, hopefully, you're like going, yep, I get it. I add them if they've got the same base, the same letter, basically. All right, so next, I'll just delete. Let's delete. Just want to clear it out a bit. Okay, now this one, the second rule is when you are dividing terms with algebra terms that have letters in them. So if we were doing it without letters, we might be saying we've got a number 12 and we're dividing it by 6. So there's no letters in this one, so it's not algebra. We're just going to say, well, what's the highest common multiple that goes into both? And we know 6 goes into 6 times 1, so we can say that 6 goes into that once, and 6 goes into that twice. So that's what we end up with. The answer is 2 over 1, and you don't write, when you've got over 1, you don't write the over 1 part, you just write 2, don't you? But it is 2 over 1 is the answer, but you don't never write over 1. So your answer 12 divided by 6 is 2. Yeah, so that's basically when you're dividing stuff that hasn't got letters in it. Now, there is a rule if they do have letters in it. So when you're doing algebra and there are letters, then you have to do the rule. But let's try this one. Say, we'll just do it without letters first, just to make sure you understand it. So if I go 12 divided by 12, and I go, what's the highest multiple that I can multiply to get 12? And it's 12 times 1. So the highest multiple is 12. So if I go 12 divided by 12, it's equal to 1. And if I go 12 divided by 12, that's equal to 1, isn't it? So 12 divided by 12 is the same as 1 over 1, which is what? It's the same as 1. Yeah, so 12 divided by 12 is equal to 1. Well, the same thing happens if you go A divided by A. That is exactly the same. It's also equal to 1. In fact, any numerator and denominator that are the same will always equal 1. So B divided by B, yep, the same numerator and denominator, it's going to be equal to 1, okay? Right, so remember it's 1 over 1, and I explained how you get 1 over 1, which is the same as 1. 1 over 1 is the same as 1, because you never write the 1 underneath. Okay, so now that you've got that basic understanding about anything divided by itself is equal to 1, that helps a little bit, so it makes sense. Okay, so we have a question here, and it says, we're dividing, and we're involving indices, okay? And our rule is you subtract indices. All right, so let's try doing this. Let's go, let's add some indices. So we're going to say a to the power of 3, and we're going to divide it. Divide sometimes looks like this. Divide sometimes looks like that. But, so I'll write it like this so you can see it. So if we do it like this, we have a rule, and the rule is when you're dividing, you subtract the indices. So this would be the same as writing this. A to the 3, and so the indice is the little number, remember? And we're just subtracting that, and that will leave us with 3 minus 2 is 1. So it'll leave me a to the 1, or just a. Okay, there's our subtraction. Yeah? Okay, hopefully that makes sense. We just subtract. All right, let's write it a different way. The same question, but write it a different way. This time, so you can sort of see similar to what we did before. So if I go a divided by like this, now what does this mean? This is the same as writing it like this. I've got a times a times a. Let's see if it, hopefully that it's making sense, is starting to make sense to you, because the rule is just subtract, okay? But I'm trying to explain it a little bit easier so it fully makes sense. So now I could have, this is how I could have written this question here. A to the power of 3 is the same as multiplying the a 3 times. A to the power of 2 is the same as multiplying a twice. Now, remember when I said anything divided by itself is equal to 1? Well, look at this. I've got an a divided by a. Because the minus, I can say, yeah, well, let's just a divided by a. That's the same as 1 over 1 or 1. So we can just say, yeah, we'll just cancel them out. Because it's the same as 1, having 1 on the top, 1 on the bottom. And remember, you don't have to write it if it's 1, eh? Okay, I've got an a divided by an a again. Yep, so we'll say, oh, yep, let's cancel that out. And so what are we left with? We're left with an a on the top and only a 1 on the bottom. Why is there a 1 on the bottom? Because that, remember, that cancelled out to 1. That cancelled out to 1, so that's 1 over 1, 1 over 1. So 1 times 1 is 1. So it's actually just a over 1, and remember, you never write the over 1 part. So we're left with an answer that basically is just a. Now, did that work out to the same thing with the subtracting the indices? Let's have a look. 3 times 2 leaves us with, so if I take away 2 on the bottom from the 2 on the top, is left. I'm left with 1a on the top. So what's our answer? It's exactly the same, isn't it? 1 on the top, a to the power of 1, yep. And on the bottom is just a 1, because it's cancelled out. Nothing left apart from a 1. So see how it worked out? 3 of them on the top, 2 of them on the bottom. There's only a 1 left on the bottom, and there's 1a left on the top. So it works out. Let's try a different one, because we want to get this dividing really, really well done. So how about we go, let's try 7 of them on the top, and this time 10 of them on the bottom. Oh, sorry, my bad. Just using any letter, it doesn't matter about the letter. A is just the letter I'm using. Okay, so I've got A7, remember, is the same as writing A times A times A times A 7 times. And I've got A to the 10, which is the same as writing A times A times A 10 times. So it's simplified. So when I've got this rule, letters divided by letters, I subtract indices. So let's do this. Okay, I've got 10 of them. I've got 7 on the top, and I've got 10 on the bottom. So there's going to be 3 of them left on the bottom, after I subtract them. 3 on the bottom, and there'll be none left on the top. Isn't there? Remember, it's the same as writing A times A, etc., etc. Yeah. Dot, dot, dot. Yeah. And A times A down the bottom. Dot, dot, dot. Yeah. So start cancelling out. So there's 7 of them on the top. I cancel out, cancel out, cancel out, cancel out. And it looks like there's 3 left still on the bottom. And there's none left on the top. So can I just write this? A to the 3. Hold on a minute. Just delete that little thing there. Sort of in the way. Can I just write that? Can I just write that? A to the 3 and 0? No, I can't do that. Because is it 0? Remember, it's not 0, is it? It's A divided by A is 1. A divided by A is 1. 1 times 1 is 1. So A divided by A is 1. So is it 0 left on the top? No, it's not 0, remember, because A divided by A is not 0, it's 1. So I leave 1 on the top. I can't put 0 because it's not 0, it's 1. 1 times 1 times 1 times 1, 7 times. So it equals 1. 1 times 1 times 1, 7 times is still 1. But on the bottom I have some A's left over that weren't divided by each other, so I've got 3 of them left. So remember the rule. Subtract. So 10, I get the biggest number and I minus it by the littler number, and it's left with 3 on the bottom, and on the top there's nothing left, so it's 1. Whew, that's a cool rule. Okay, it's a pretty crazy stuff, but hopefully it's starting to make sense. Before I move on to the last one, I really want to make sure you understand it, because if you get this rule, you've got you've got the multiplying rule and you've got the dividing rule, so you're actually doing all right. Okay, and that means you've got two of the rules for indices, and when you learn the last one, there's 3 of them, and you're on your way. So at level 1, they'll probably add more rules, but it doesn't matter. You've got some really good basic rules. Okay, so let's try 10 x to the power of 3 divided by 5 x to the power of 2. Okay, now we're asked to simplify that. Right, so when I'm doing this, remember, I deal with the numbers first. Okay, do the numbers first. So I just deal with that first, and then I deal with use the rule, which is subtract. So when I'm doing this part, I go 10 divided by 5. That is like 10 divided by 5 is 2, isn't it? Yep. Or 2 over 1. 5 goes into 5 once, goes into 10 twice. So 10 divided by 5 is 2. Great. So I've done the numbers part. Now I deal with the same base. I've got the same base, x. So I can do my rule. If this was not this, if they weren't x's, we couldn't simplify it, okay? So what's my rule? 3 minus 2. So 2 of them get cancelled out, but there's 1 left on the top. So my answer is 2x over 1, which is the same as writing 2x. There it is. Easy peasy. Real easy. Okay. There's our rule number 2 done, okay? Just subtract. If they have the same base, the same letter base, you just subtract. If it was x squared over y squared, like that, we wouldn't be able to simplify that, because x and y are different bases, so we couldn't go 2 minus 2. Okay, we couldn't do that. Okay, great. There's rule number 2 sorted. Let's focus now on rule number 3 of the indice rules. And hopefully you're mastering these indice rules, because there's only there's the plus and minus rules, which is like terms, and then the indice rules where we're dealing with the exponent, the little numbers. And these are the ones when we're multiplying or dividing, or in this case now raising to a power. Now, what is raising to a power? I've got x to the power of 3, yeah, which is the same as x times x times x, and I'm putting it in parentheses like that, and I'm saying, let's raise it to the power of 2. Now, what do I do with that? Okay, so the rule is, if you look at it, when you're raising to a power, which is this, x to the power of 3, and then to another power, you multiply the indices. So in this case, it would be x to the power of 3 times 2. Which would give us what? Yep, x to the 6. Okay, so what's the rule? When raising to the power, that means I've got a letter to the power of something. I'm in parentheses and I'm raising it to another power. Could you raise it to another power? Let's do a real crazy one. Let's go x to the power of 2. Raise it to the power of 2. And raise it to the power of 2. Whoa, crazy. So we've got x to the power of 2 raised to the power of 2 raised, and that's raised to the power of 2. So the rule is multiply indices. So that would be the same as x times 2 times 2 times 2, wouldn't it? So 2 times 2 is 4, times 2 is 8. So the answer would be x to the 8. Okay, so raising to the power is just multiplying, okay? So let's look at this example here. I've got a to the power of 3 raised to the 2. What's it going to be? What's our rule? It is a to the 3. And our rule is multiply them. So I multiply them. And so my answer is going to be a to the 6, isn't it? Awesome. There's the rule. Pretty easy rule, isn't it? Okay, now let's mix it up and make it a bit harder, because I did this one raised to a power to a power. That was sort of a little harder. But let's mix up this one, these easy questions. Let's make them a little harder just so you really understand it. All right, say I get a 2, b this time. And that b is to the power of 3. But then it's a crazy question where it says, yeah, and let's raise that to the power of 2. Okay. Ooh, okay, this is a better one, isn't it? Okay. When I was doing the multiply, I deal with the numbers first. Well, I do the same thing. I'm going to deal with the 2 first. That isn't the letter. So 2 to the power of 2, so let's write it out, is this. 2 to the power of 2. That's what that is. 2 to the power of 2. And that equals what? 4. Great. So I've done the letters. I do the numbers first, okay? So I've done the numbers. I've dealt with the numbers. Now I'm going to do the next one, which is the b to the power of 3 raised to the 2. Raised to that. So I'm going to go b now to the power of 3 times 2, which gives me b to the 6. Okay, great. So we've got an answer. So when you're doing these, if you're doing one of these raising the power and it's got a numbers in there, do the numbers first, then do the rule, raised to the power second. Do the rule second. And that is algebra indice rules for year 10 that you want to master and make sure you can do. So you've got some good basis for indice rules. Great, there's 3 indice rules that you can master. I hope you've learned something.